So now let's talk about factoring. Whenever you're factoring, let's say you're factoring a number like 12. Whenever you're asked to factor 12, you are asked to find two numbers that would multiply, like 3 and 4, to be 12. Well, 3 times 4, they're factors of 12. And so we would say that 12 could be factored into 3 times 4. Well, whenever you have an expression with algebra, like an algebraic expression like a polynomial, x squared minus x, maybe plus 6, wouldn't be plus 6, it would be minus 6. Minus 6, if you're asked to factor this, then you're going to be asked to find two things that would multiply to give you x squared minus x minus 6. So factoring is like dividing, but you check by multiplying to see if you get the result. So whenever you're factoring, I want you to think of it like I have here in this flow chart. So I want you to think of this flowchart whenever you're factoring any type of polynomial. I want you to see, okay, I've got a problem. It's asking me to factor. And then I want you to think, okay, well, is there a greatest common factor? Is there a number that would go into all three of those coefficients? Or is there a number or a variable that they all have in common? Then I'm going to ask you to count their terms. Are there 2 terms, 3 terms, or 4 terms? Well, if there are 2 terms, then what I want you to do is I want you to see if what you have is a difference of squares, because whenever you just see 2 terms after you factored out the greatest common factor, then you need to check to see if you have a special case. And this chapter, we're going to do, I think, 2 special cases. But today you only need to know about one special case, and that special case is called a difference of squares. And it follows a pattern a squared minus b squared. And it's called a difference of squares because the word difference means subtraction. And it has the word squares in it because you're subtracting a perfect square minus a perfect square. So if you see one perfect square subtracting another perfect square, that follows the factoring pattern a plus b times a minus b, where a is the square root of a squared and b is the square root of b squared. So let's try a couple of those examples. So I look at number 1 here. That 22 I think is just an extra stray mark. So get this menu out. Okay, so x squared minus 64. I see that x squared is a perfect square, and I see that 64 is a perfect square. There's only 2 terms. There's no greatest common factor. So I'll go ahead and set up 2 binomials. Then I think, okay, what's the square root of x squared? It's x, because x times x is x squared. The square root of 64 is 8. And then the factoring pattern calls for me to have a plus and a minus. And I'm done. I don't have to worry about anything else. And then if you go to the one right beside it, 9x squared minus 16. Oh, look, those are both perfect squares. So the square root, I'm going to take the square root of each. There's no greatest common factor between 9 and 16. The square root of 9x squared is 3x, because 3x times 3x is 9x squared. And the square root of 16 is 4. So I'll make 1 plus, 1 minus. Difference of squares. If you have 2 variables, just as easy. Set up 2 sets of parentheses. Y, square root of x squared is x. Make 1 a plus and 1 a minus. Then sometimes you might have something like, let's look at something where, let's look at 27. X to the 8th minus y to the 8th. Those are perfect squares. Now, when you take the square root of an exponent, you divide the exponent in 2. So the square root of x to the 8th is x to the 4th. And this, so x to the 4th. Then the square root of y to the 8th is y to the 4th. Make 1 plus and 1 minus. Now, I could say, oh my goodness, look. I have a minus right here, so that makes this second binomial another difference of squares. So the second binomial, I could factor it further and have the square root of x to the 4th is x squared. The square root of y to the 4th is y squared. Make 1 plus and 1 minus. And then you still have to bring down the x to the 4th, y to the 4th. That part does not factor any further because it's not a difference of squares, it's a sum. Okay, then you get there and think, oh, okay, I'm done. But wait, I have another difference of squares right here. So I can factor that part even further. The square root of x squared and the square root of y squared. The square root of x squared is x. The square root of y squared is y. Make 1 plus, 1 minus. And then we'll bring over the x squared plus y squared, which does not factor any further because it's a sum. And I put that squared in the wrong place. And then bring over the x to the 4th plus y to the 4th. All right, so that's what you'll do if you have 2 terms. If you have 3 terms, there are several methods you can do, but if you have 3 terms, what you want to end up with is something that will factor. If you have 3 terms, you're going to try to see if it will factor into 2 binomials. Two binomials meaning 2 sets of parentheses. Now, there's a couple of different ways you may have learned this in the past. There's something called like guess and check, trial and error. There's another method called Xbox. There is another method called the AC method. And again, all of these methods are great. You will see me, and I'll do this one in the video, you'll see me use guess and check the most because it requires the least amount of writing. That doesn't mean it's the best, that's just the one I prefer. Now, if you don't like guess and check, you are welcome to find another video that shows you how to do the Xbox method or the AC method to factor, or maybe you just remember it on your own, but totally fine on either of them, but you'll see me demonstrate guess and check the most. Now, you can always schedule a help session with you. I'll be happy to help you with any others. But let's look at these 3 terms. I didn't give myself enough space on this first, so I'm going to mark those off. Okay, so here's what you're going to need to do. If you're going to use the guess and check method, you're going to need to be writing with something that erases. So whether that is a pencil, or maybe you're using a whiteboard or a highlighter or something, or even if you don't have a whiteboard, maybe you use your binder and you can write on that. But you need something that's going to erase. So here's what you're going to do. You're going to go ahead and set up your 2 sets of parentheses. Parentheses, parentheses. All right, then you look at the first term, 3n squared, and you think, okay, what are 2 things that will multiply to be 3? Well, my only factors for 3 are 1 and 3. Whoops, 1 and 3. So to get 3n squared, computer's trying to catch up with me here. So to get 3n squared, the only way I can do that is to have a 1n times a 3n. Hold on, I'm trying to catch up with my computer here. 1n times a 3n. Now, you might not need to write the 1 in. You can just write n. That's fine. Then you look at this last term, 5, and you think, okay, what are my factors of 5? 1 times 5. So I'm going to try 1 and 5. So I'll put the 1 here and the 5 there. I don't know if that's right or not. I'm guessing. This is guess and check. So you'll know if you've done the right thing if this product, add or subtracted with that product, combined to be negative 8. So I look at the product of 5n and 3n and I get 15n. Then I look at the product of 1n and 1 and I get 1n. Is there any way I can add or subtract 15n and 1n to get negative 8n? No. Okay. So let me erase. Okay, instead of 5 and 1, maybe now I'll try 1 and 5. Okay, again, I'm trying to combine this product with that product to get negative 8. Well, 1 times 3 is 3n. And 1n times 5 is 5n. Now, if I'm trying to combine these to get negative 8n, if the 3 is negative and the 5 is negative, they'll combine to be negative 8n. So I'll have 1n minus 1, 3n minus 5. So then my final factorization of this is n minus 1 times 3n minus 5. So this is my answer. Now, if I want to check my work and see if I am correct, I can multiply this back out and see if I get the same answer, or the same as the question. So n times 3n is 3n squared. N times negative 5 is minus 5n, minus 3n plus 5, combine like terms. 3n minus 8n plus 5. Is that the same as the question? 3n squared minus 8n plus 5? Yes, it is. So that means my factorization that I did is correct. So this is the correct factorization. I can do another one of those examples. So let's look at this one that's labeled number 12. I have 3 terms. So I am going to separate into 2 binomials. I'm going to think about the number 5. The only way to get 5 is to multiply 1 times 5. So I'm going to say k times 5k. Then I'm going to think about the number 54. And I'm going to think of factors that multiply to be 54. So 1 times 54. 2 times 2 times, what is 54 divided by 2? Had to grab my calculator. Okay, so 2 times 27. What else multiplies to be 54? Maybe 54 divided by 3. 3 and 18. 54 divided by 4. Nope. 54 divided by 5. No. 54 divided by 6. 6 and 9. And I think that's all the factors. All right. So now I'm going to try any factors I want. Let's try 6 and 9 because it's at the bottom of the list. So I put 6 here, put 9 there. Let's see if this works. Let's see, the product is 30k. K times 9 is 9k. And I'm trying to multiply and get positive 39. Well, let's see. It will work if I have a positive 30 and a positive 9. So I could put a plus here and a plus here, but I do need to double check. Is positive 6 times positive 9 negative 54? No. Okay, so maybe it's not 6 and 9. Maybe it's 9 and 6. So try switching the order. So instead of 6 and 9, let me try 9, and 6. Okay, 5 times 9 is 45k. K times 6 is 6k. Can I add or subtract those? Well, if I have a positive 49 and a negative 6, that would combine to be positive 39. So I would have a plus. Now I'm going to follow this path right here to get the plus 9, and then follow this path to get minus 6. So this factors into k plus 9 and 5k minus 6. Now, it will be, I'm going to be honest, the guess and check method is going to be frustrating at the beginning because you'll feel like you're trying a bunch of factors and you can't get it to work out. But trust me, you'll get faster at this as you go, and you'll get better at this as you go. So I strongly encourage that you use something that you can erase on. So if you do have a whiteboard marker or even a highlighter in your house that you can write on something and erase, that will at least make this process a little more fun. Don't recommend pens at all for this. All right, if you have 4 terms, you need to use a method called grouping. And so when you're using grouping, let me find an example. Grouping, grouping. There's a set of steps that you're going to need to follow. So let me find a grouping example. Okay. So step 1 is going to be split into 2 groups. So step 1 with grouping. You're going to split into 2 groups. So I'm going to try this one that says number 20. So I have a group here and a group there. Okay, step 2. You're going to factor out the greatest common factor from each group. So I look at my first group, I see 30 and 35, and I notice that they both have a 5. They both are divisible by 5. So the greatest common factor of my first group has a 5 as the coefficient, and they have one term has an x cubed and the other has an x squared. So they both at least have 2 x's, or at least an x squared. So the greatest common factor of my first group is the 5x squared. So that means I'm going to factor a 5x squared out of the first group. In the second group, I look at 36 and I look at 42, and I say, oh, I can divide both of those by 6. So the greatest common factor will be 6, and 36 has an x, but 42 does not. So I won't have a variable in my greatest common factor. Also notice that in front of that 36 is a negative. So anytime there's a negative in front of that in front of the second group, go ahead and factor out a negative with that greatest common factor. So out of the second group, I'm going to factor a negative 6. So when I do that, when I factor out the 5x squared, I divide 30x cubed by 5x squared, and 30 divided by 5 is 6, and x cubed divided by x squared is x. When I divide negative 35x squared by 5x squared, I get minus 7. Then for the second group, I'm going to factor out negative 6 from negative 36x. So negative 36x divided by negative 6 is positive 6x, and 42 divided by negative 6 is minus 7. Now, I don't know if you're noticing yet, but these 2 binomials are the same. Well, not exactly the same. They look exactly the same. They're just in different positions. That's what we want to happen. If that does not happen, then you either did something wrong or the problem doesn't factor. So most of the time it's that you did something wrong. Sorry, but that's how it is. Okay, so step 3 then is going to be to factor out factor out the binomial GCF. Pen is slowing down. GCF. So the binomial GCF is what I just highlighted above. So in this case, I'm going to be factoring out the 6x minus 7. So I'm factoring out the 6x minus 7, which is the binomial GCF. And whenever I do that, I'm left with 5x squared. What's on the outside? Minus 6. And that